Okay, so today in college algebra we are solving some higher order equations that just so happen to be factorable. Okay, these are all going to be cubic and fourth degree polynomials. And like it says, not all of them can be solved this way, but when they can solve it this way, it's really easy. Okay, these techniques you've learned before to solve, including solving by square rooting once we get some squares and such. So it really makes kind of good sense. It's a good application of just about everything we've learned so far about factorable polynomials in quadratics. So we're going to start off with the ones that look like this. There are two terms. Both of them have x's in common. So you should know that how you factor this one is by taking out the things that they have in common. So we're going to factor this in common factor style. Okay, just like you do with in Algebra 1 when you have lots of polynomials together, lots of terms, you see what they all have in common. So we should notice that both the first term and the second term have a common multiplier of 4 as well as a common multiplier of x squared. So we pull out the 4x squared, and what we have left is just a regular x squared minus 9 is the factor that's left over. And we do this, of course, so that we have multiplication. So we are multiplying this 4x squared term by this x squared minus 9 term. And if you were to distribute it, we would, of course, get exactly what we started. So we want to find the numbers that multiply to give you 0, which means that either this term has to be the 0 term, or our x squared minus 9 has to be the 0. Okay, one of these two things must be 0 in order for their product to be 0, which is why we factor in the first place, so that we have multiplication, not subtraction. So if we were to solve this one, of course, we can divide by 4, and all of you should know how to do this already. X squared, we take the square roots, and we get x equals 0. Okay, it makes perfectly good sense that 4 times 0 to the 4th power minus 36 times 0 squared gives you 0. Because 0 times anything is 0. And over here we solve this one, we'll add 9 to both sides. This is an easy squared solver. When we square root both of these, we get the positive of 3 and the negative of 3. Okay, sometimes when we take a square root, you only get the positive value, but whenever you are solving a squared equation, you get a positive and a negative value. Okay, many of you might be thinking, wait, this is a 4th degree polynomial. I'm supposed to get 4 answers. Well, it's true. We do have 3 solutions here, but 0 would be a double root. Okay, x squared equals 0, so because we're squaring 0, 0 is your double root. It takes care of 2 of them. Then here's your 3rd answer, and here's your 4th answer. Okay, so there are actually 4 solutions to this 4th degree polynomial. Just one of them happens to be repeated twice. Okay, so solving with common factors is a very easy way to do it as long as both terms have something in common. Okay, so here's another type. This is a cubic equation, a 4-term cubic equation. We're going to solve this one by grouping. Okay, this is a very common way to solve a cubic with 4 terms. A 4-term cubic is to group them together and see what they have in common. So solving by grouping, we group the first 2 terms together, and we group the second 2 terms together. And we need to think, what does a 2x cubed and an 8x squared have as a common multiplier? Okay, and we notice that it has a 2x squared. Both terms have that as their multiplier, which leaves us with just an x plus 4 left over. Okay, this is 2x to the 3rd, 8x squared. They have 2x squared in common. And when we divide both of these things by 2x squared, this is what we have left. Now a minus 4x and a minus 16 both have a minus 4 in common, leaving me with an x plus 4 as the leftover factor. Okay, many of you might ask, wait, it was a minus here And now it's a plus. Where did that minus go? Where we factored it out to right here. So if we were to redistribute negative 4 times x, that gives you your minus 4x. Negative 4 times positive 4 gives you your minus 16. So whenever you factor out a negative value, the sign inside of your parentheses is always going to change, so that when you remultiply, it will go back to what it originally was. So now we can look at this term. What does this whole entire term and this whole entire term have in common? And we should notice that they both have a parenthetical x plus 4 in common. So now we're factoring out this common multiplier, and we write down what's left over, which in this case is a 2x squared minus 4. Okay, this is how we factor by grouping. Because this is not multiplication yet, this is still subtraction. So with one more factorization, we get our multiplication. So according to the zero product principle, either this term has to be 0, or the 2x squared minus 4 term has to be 0. So solving this one, we'll subtract 4 from both sides. We get x equals negative 4 as one of our solutions. And we'll solve this one over here likewise. So we add the 4 to both sides, giving us a 2x squared equals 4. We divide both sides by 2, because you only ever want to square root one thing. So x squared equals 2. And whenever we square root something, we get two answers. We get a positive root 2, and we get a negative root 2. So plus and minus square root of 2. Now because root 2 is not simple, or is not pretty, it's not a perfect square, just leave it underneath your radical. You can, if your teacher wants, write that down as a decimal, but I would much rather see a radical 2 as an answer than the 1 point, whatever that happens to be, as a decimal. But of course, do what your instructor wants you to do. Just know that it's root 2. Okay, so here we have a third degree polynomial. Here are your three answers that you would expect to have. Negative 4, positive root 2, and negative root 2. Okay, factor by grouping. So let's do one more example of factoring by grouping, just to make sure we've got it. This is going to be a little bit different, sort of more complicated maybe. So we group them together, the first two things and the second two things. 8x cubed, 20x squared, both have a 4x squared as your multiplier. This is 4 times 2, that's 4 times 5, leaving me with a 2x plus 5 as the leftover factor. Now a minus 2x and a minus 5 have a minus in common. So now I'm going to pull out a negative 1. Okay, yes, it's hard to see 1 as a common multiplier because everything is multiplied by 1. But in this case, we're going to pull out the negative. So we have a 2x plus 5 as the leftover factor. Okay, these two parenthetical things must be exactly the same if you're going to be able to common factor them out. So now that they both have the 2x plus 5 in common, we're going to common factor 2x plus 5 out, leaving us with a 4x squared minus 1 as the other factorization. Okay? So even though it doesn't look like these things have anything in common, writing down your minus 1 here leads you to have a really nice parenthetical factor right here. Okay, without that, it might be a little confusing. 4x goes with what? Well, it goes with the minus 1 as the leftover. Okay, so it's helpful to be able to see that. So now we go, when we solve this, either 2x plus 5 equals 0 or 4x squared minus 1 equals 0. Okay, so with a couple of steps, we can get these solutions pretty quickly. 2x equals negative 5, divide by 2. So I'm just going to leave this as a fraction. You can, of course, write it as 2.5 if you wish. But 5 halves, negative 5 halves is one of your solutions, or 2.5. So over here we add 1 to both sides. 4x squared equals 1. We'll divide both sides by 4. So x squared equals 1/4. Now when we square root both sides, we have to see, can we simplify either one of these two radicals? Okay, we can split this up and make this the square root of 1 over the square root of 4. And it's handy to do if both of these are perfect squares, because 1 does have a square root, 4 does have a square root. So if we take the square root of 1/4, we get positive 1/2 and negative 1/2. So rather than leaving that as a radical, you actually take their square roots, because 1 and 4 are both perfect squares. 1/4 has a square root, and that square root is positive and negative 1/2. Okay, so those are your three answers in this case: negative 5/2, positive 1/2, and negative 1/2. Okay, so if both of your fractions come out to be perfect squares, you can take their square roots and simplify them a little bit. Okay, so there's two examples of factoring by grouping. Now let's move on to some other types of factorizations. So here, if you'll notice, we have an x to the 4th and an x squared and then a no x term. Okay? So this is not exactly the same, but we're going to factor this like we would factor any old rather quadratic equation. Okay, because it's sort of quadratic-like. In that, we have an x term that's twice this one that has nothing there. Okay, so this is a quadratic-like 4th degree polynomial. So I'm going to factor it like we would factor any other quadratic. What numbers multiply to give you 9 and add to give negative 10? Okay, these help you find your factors, which are, of course, going to be negative 9 and negative 1. Okay, but rather than with the quadratic, when we had an x squared term here, your factors aren't going to be x plus and minus, but rather x squared minus 9 and x squared minus 1. Okay, with quadratics, your factors are linear. If this were an x squared here, we would just have an x minus 9 factor. But because our polynomial is a 4th degree, you need an x squared times an x squared to give you that x to the 4th. So 4th degree quadratic-like ones factor to x squareds rather than to just x's. So now that we have our factors, we set them equal to 0 and solve, once again, like we would do any other quadratic type equation. So x squared equals 9. So x equals positive and negative 3. X squared equals 1. So x equals positive and negative 1. When you take the square root of 1, just remember the square root of 1 is its actual self, positive and negative 1. Okay, so this is an excellent type of factorization if we have an x to the 4th term, an x squared term, and a number term. So the very first example, there wasn't this number term, so we had to common factor these things out. But because we have this number, we can factor like we would do any other quadratic. Only you have x squared factors, not linear factors. Okay, so here's another example. This time we have a leading coefficient, but we're still going to factor it like we would any other quadratic. So because it has a leading coefficient, we do the 3 times negative 2 to give us a negative 6 on top, and we still have a 5 on the bottom. So we're looking for numbers that multiply to give you negative 6 and add to give 5. Those would be 6 and negative 1. But because we multiplied by 3 to get on top, we have to divide by 3 to get our factors. And once again, because this is a 4th degree, we're going to have x squared as the factorization rather than just an x. So 3 divides 6. 6 divided by 3 is 2. 3 does not divide negative 1, so that becomes your coefficient factor. Okay, so because 3 divides 6, you actually divide it. 3 does not divide negative 1, so the 3 becomes your coefficient and the negative 1 becomes your number. Okay, so now we apply once again the zero product principle. Either this thing has to be 0 or this thing has to be 0. So minus 2 minus 2, x squared equals negative 2. When we square root this, can we take the square root of a negative? No, we cannot, but we can imagine that we can. So we get positive and negative I times the square root of 2. Okay, the I comes from your negative, and the root 2 just stays there. So we have two imaginary solutions. Plus 1 plus 1. 3x squared equals 1. Divide both sides by 3. And then finally square root. And the other factors are the square root of 1/3. And you can ask, well, last time we reduced this, it was 1 over 4, and that became 1/2. Well, that was nice because both 1 and 4 are perfect squares. In this case, 3 is not a perfect square. So having just square rooting the top doesn't make it look any nicer. So just leave it as a square root of the fraction in this case, rather than simplifying your square. Okay, and I believe there's one more example. Here we have a 5x to the 4th equals 40 times x. So what we want to do here is make this equal to 0. So I'm going to subtract my 40x from both sides, so that I have something that I can now factor. So 5x to the 4th minus 40 times x both have a 5 and an x in common, leaving me with an x cubed minus 8 as my factor. So either 5 times x has to be equal to 0, or x cubed minus 8 equals 0. Okay, and of course, when we divide both sides by 5, 0 is one of your answers. Here we will solve this plus 8 plus 8. X cubed equals 8. We solve a cube by taking its cubed root. Now, is there a cube root of 8? Yes, there is. That number is 2. So we have answers of 0 and 2. And once again, you say, wait, this is a 4th degree polynomial. We're supposed to have 4 answers. Well, here x is 1, and in this case, 2 is going to be a triple root. The 3 of the answers are going to be 2's because you took the 3rd root. 2 times 2 times 2. And we don't repeat our answers in math because we don't like to be repetitious, even though the problems we do are the same over and over and over again. Okay, so they're solving some higher order polynomials that are factorable. Okay, lots of different ways to factor. Hope you understand stuff and have a great day.